talk about how we folded the sheet. So first we took an 8x inch paper and we folded it in half. So then we opened it up and we took the little flap that we made and folded those two in half. Here we are doing the first flap, and then we move over to the second flap. Once that's done, we leave it like so, and we turn it on its side, and we take the bottom right hand corner and fold it upwards into a triangle. And then we repeat this on the left side. Now we have this like weird shape, so we take the little triangle right there and we fold it inwards, and we take this flap on the top and we fold it down under that sheet. And then we repeat this on the opposite side. Now that we have that, we have this weird little diamond-y shape. And so we fold the triangles next to each other and make a crown-ish looking shape. And then we take one of the triangles and we fold it over. And then we take the next triangle and we fold it back. So then we have triangles. And then when you fold it up, it's perfect, like so. In total, we had to fold 12 of the little sheets that we showed you previously. So here we're just laying them out so you can see. Here we're going to show you how we put together the triangles. We're going to put 3 of the little diamond-y shapes together to form one of the sides. First, you put the first triangle into one of the little flaps of the second triangle, and then you grab a third flap and then you put that into the second triangle's flap. And so then you have this weird spidery 3-pointed shape. And you are going to make 8 of those. And there you go. Finally, here we have that where we're going to actually put together the octahedron that we folded up and created. So we're putting together all the little spidery 3 spindly paper things that we've showed you previously. So here we're just putting them together the same way that we put together the 3 individual ones. So we're we're sliding in the corners of our papers and into other flaps. So here you can see that we're putting it together, and it was a lot more complicated than it looked originally. So yes, ignore us having trouble with it. Okay, so here we've connected 2, so then we have this other one to connect. Finally, we're going to put this one in the same way we put in the other one. Okay, so you can see we're putting it into that open flap. There we are, sliding it in. And we just secure it. And now we slide this flap into this opened flap. Slide it in. Now we're down to our last 2. So this corner we're going to slide in there. And there you go. We have our octahedron. So now we're going to take the area of one triangle to find the surface area of the entire shape. So the base is 4 inches and the height is 2 inches. And so the area of a triangle is base times height divided by 2. So we plugged in the numbers and we get the area is equal to 4 inches squared. So now we're going to multiply by 3 because the prism has 3 sides as shown here. 1, 2, 3. So now we get 12 inches squared. So then we're going to multiply by 8 because there's 8 little prisms on each side, as you can see here. And so now we get the surface area is 96 inches squared. So now we're going to find the volume. So we're going to find the volume of the inside, and we're going to be excluding the prisms so we can find that afterwards. So the volume is base times height times width for the cube. So it's 4 times 4 times 4, and then we have 64 inches cubed. So now we're going to find the volume of the prisms. So for a prism, we have the volume is 1/3 times the area of a triangle times height. So the area, as we found earlier, was 4, and the height is 1.5. So we substituted everything in and we got 2. So now we're going to multiply by 8 because there's 8 prisms, and we get 16 inches cubed. So now we're going to add that to our previous volume of 64 and we get a total of 80.
Nah, this is boring. Let me tell you what calc is truly about. Lots of restless nights in Saturday schools, you get into derivative properties like chain rule. Learning about a function's minimax. Ain't no thing is trying to relax. The only Cal gang initiation is the knowledge of differentiation. We were taught MVT, IVT, and EVT. Did we pass the AP exam? We'll have to wait and see. Only thing we always forget is the plus C. Still not as bad as the stress of a series. Difficulty in integration by parts, you say? Never. We got taught through the ate. Mr. Brown triple dog told me not to do my homework. Now I got a B because I didn't do the groundwork. Made it through the year, and now I know sequences, series, parametrics, polars, and integration. Nothing in my way other than my soul calc intimidation. It's just algebra. When I see the question rule, I don't get scared. Knowing the formula and denominator is squared. Riemann sum is blessing to us, left or right. Even middle and trapezoid are all cake at our sight. If you don't know them by now, what you've been doing other than memorizing 36 formulas since the beginning.
Hold up, let me help you out, cause I got the clout. The year wasn't only about the math, but also about the students and teach, saying Mr. Brown Rosa's aim to reach. He may have taught us through the year, but he made sure by the end we were in tears. I learned properties of exponents, logs, and trig each day. Was told we were the challenge class and having no say. I got some difference and product was down. Finished the AP test, now ready to leave town. The OG Raymond Brown taught us the way. Gotta stay on the path in order to repay from day to day. Can't run away. Miraculous if I got a 9 on an FIQ using FCC 1 or 2. He says I can't derive, so how could I get a 5? Oh.
Deuces, my peeps.